sphere X falls through a fluid with terminal velocity v. Sphere Y is made of the same material and falls through the same fluid. The radius of sphere Y is double that of sphere X. What is the terminal velocity of sphere Y? A fluid is a common name for a gas and for a liquid. And let's consider forces acting on a sphere when it is moving in a liquid. Definitely its weight mg, and since it is moving in a liquid, there is additional drag force which opposes motion, so it's upwards, and the formula is given in a data booklet, and it's 6 pi viscosity. It depends on the liquid eta, and multiplied by the radius of a sphere and multiplied by the velocity of a sphere. And there is also the buoyancy force, which is always upwards, and it is equal to the weight of the displaced liquid, and it's rho of liquid, the liquid multiplied by g and multiplied by the volume of a sphere. And initially the sphere is moving with acceleration, and hence its speed increases, but you can see that the drag force depends on the speed of the object, and when speed increases, this drag force also increases, and at some moment of time weight will be balanced by the drag force and the buoyancy force, so that its acceleration is equal to 0, and velocity at that moment of time is called the terminal velocity. So mg is equal to 6 pi eta rv plus rho l gv, and this v is the required terminal velocity. It's just second Newton's law. F is ma, a is 0, or acceleration is 0, it means all forces are balanced. And we need just solve for v. And what is m? It's density times volume, density of the sphere, and volume, it's a sphere, so it's 4 over 3 pi radius cubed times g is 6 pi eta r v plus rho liquid g, and it's also volume of a sphere, 4 over 3 pi radius cubed. And you can see we can divide each term by r to get r squared here and r squared here. And if we solve for v, the required terminal velocity, you can see that it becomes some constant multiplied by r squared minus another constant multiplied by r squared. R squared can be factored out, and it becomes some constant multiplied by r squared and divided by another constant. So finally you can see that the terminal velocity is proportional to radius squared, and if radius increases by factor of 2, the terminal velocity increases by factor of 4. So D is correct. And that's all for this question.